Hey, we're here to start Unit 7. Unit 7, we're going to discuss right triangles. We're going to start that by doing sort of a review here of the Pythagorean theorem. So remember that the Pythagorean theorem gives us a relationship between the sides of a right triangle. And the relationship here is a squared plus b squared equals c squared. So something we've talked about already. And a and b come from the two legs of the triangle, and c comes from the length of the hypotenuse. Remember, the hypotenuse is across from the right angle in a triangle, and that's always c. So we've used this to check whether or not a triangle is obtuse, acute, or if it is a right triangle, and here we're going to use it to find the length of a missing side. The first way we can do that is if we have a side that's a leg missing. So here we have a hypotenuse that's 20. And we have one of the legs is 8 and one of the legs is x, and we want to find the length of that leg. So we should always start by writing the Pythagorean theorem, and then we'll plug in what we know. If I'm missing a leg, I like to make that length, that x or whatever variable we use, I like to make it the a squared piece. We'll plug 8 in for the other leg and 20 in for the hypotenuse, and then we can just simplify. If the x squared's over here all the way to the left, it just makes it very easy to know that I need to subtract 64 from both sides. Now I can take the square root of both sides, and I end up with x being the square root of 336. Now you could simplify this into a simpler radical form. That would be something that you did in algebra. We don't really want to round it because we're talking about a length, so we can leave it like this for now. Here's another example. I have 12 as my hypotenuse. It's across from the right angle. And I have one leg that's x, and I have one leg that's 6. So again, I start by writing the Pythagorean theorem. If I write it every time, I'll remember it better. And again, I plug x in for a squared. You don't have to do that, it's just a recommendation. Plug in my other leg length 6 and my hypotenuse length 12, and then I can simplify. Subtract 36 from both sides, and I can find the square root of both sides, and I get that x is the square root of 108. Again, as a review from algebra, we can simplify this into the simplest radical form. We're not going to want to really put it into a decimal form and round it because we're talking about the length of a side. So we'll leave it like that for now. Another way we can apply this is if we're actually looking for the hypotenuse length. So here I have a right triangle where my two legs are 20 and 21, and my hypotenuse is x. So 20 and 21 can go in for A or B. Doesn't matter which goes in for which. I always start with my Pythagorean theorem. I'm going to plug in my two legs, and x is the hypotenuse. I simplify. I keep simplifying. I take the square root of both sides. The square root of 81 comes out nice and neat, so we get that hypotenuse length is 29. A similar example over here. I have sides that are legs that are 24 and 10, and my hypotenuse is x, so we're missing the hypotenuse again. As I have for the last few examples, I write my Pythagorean theorem. Plug 24 and 10 in for A and B. It doesn't matter. You could have 10 squared plus 24 squared if you'd like. X goes in for my hypotenuse, which is C. Do some simplifying. And then finally I get The square root of 700 or 676, I'm sorry, is 26. So the hypotenuse here is 26. Make sure you always try and take the square root to see if it is a perfect square. You might not know 676 or 841 are perfect squares, but they are, so you might as well check. So that was it. Kind of a quick review here of the Pythagorean theorem. Try these two problems, one where the hypotenuse is missing and one where the leg is missing. So find the missing length of the side using the Pythagorean theorem.